The following is a presentation of the Six Arrows Radio Network.
Today on the Workbench, we learn about microwave radio from Brian, W6BY. Stay tuned. Welcome to the Workbench. I'm your host, George, KJ6VU.
And I'm Jeremy, KF7IJZ.
This episode of the Workbench is brought to you by Elecraft, makers of high-performance radios, amplifiers, and other great station accessories. Check them out at www.elecraft.com. And by Autodesk, the makers of Eagle PCB design tools, the software we use to design all of our Workbench build projects. For more info and your free copy of Eagle, go to www.autodesk.com/Eagle today.
Welcome back to the Ham Radio 360 Workbench podcast, your bi-weekly deep dive into making and technical topics of interest to the radio amateur. This week, I am joined again by George.
Hey, Jeremy.
My absolutely faithful and wonderful co-host partner.
Nice to be here.
Good. George, we're not alone again tonight.
No, we're really lucky tonight. We have a special guest. We have Brian Yee, W6BY. Hello, Brian.
Hi, guys. Jeremy, good to meet you.
Brian.
And of course, I know George.
Fantastic to meet you.
Back in January at Baycon, Brian was one of our special guest speakers talking about microwave radio. And we've been talking about getting him on the show for a while, and he's able to make it tonight. So glad you could be with us. And the topic sounds pretty exotic, and a lot of people listening probably don't even know that you can operate ham radio in the millimeter waves and the microwaves. And tonight, Brian is going to tell us all about it.
And as a reminder to our listeners, so this week, George, I've seen a lot of activity in the Facebook group and on Twitter. People are starting to get their BitX 40s.
Yeah, we're definitely seeing people order them up, and we're trying to figure out a time to get Asher Farhan on the show so we can have him walk us through a bit of the history as well as the technical aspects of the design. So I think it's going to be a lot of fun to get him on the show.
So if, of course, if you are new and have not been listening, this is your first time with us, right now we're encouraging our listeners to visit www.hfsigs.com, where you can purchase for a mere $60 the Asher Farhan BitX 40 7-watt 40 sideband transceiver kit. And of course, this kit is requires a little bit of assembly for things like the antenna connector, the speaker, the microphone, pieces like this. All the electronics are already soldered and assembled. It's just some of these ancillary interface pieces that are available for you. But this radio is immensely cool because A, it comes to your house from India for $60 in the continental US. B, it has a lot. The way the board is laid out, it really can help you understand how a radio actually works, both the receive chain and the transmit chain. And then finally, this thing is like infinitely hackable. We talked to Smitty Halibut a couple episodes ago about an overview of this. We've mentioned some other folks doing things, put some links in previous show notes about resources of people who are doing things to make add better filtering for the audio, making it multi-band, etc. In fact, actually, the current version of the board uses a thing they call the Raduino, which is an Arduino mixed with an SI5351 frequency, not oscillator. What's the word I'm looking for?
Synthesizer.
Thank you. A frequency synthesizer to give it an even more stable tuning capability. But we're going to be using this and talking to additional people in the future about trying to get people interested in learning about the actual I was going to say the mechanics, but I guess it's the electronics of ham radio.
The request here for you listening is go ahead and pick up a kit. And the reason why we suggest you do it now is because as we get more people on the show talking about it, you'll be able to follow along and understand how the circuit is designed, how it works. We'll exchange some tips for using the radio, different ideas for packaging it, and see what other people are doing with them.
And as a reminder, when we talked to Smitty, he shared with us that he actually had made a video on his YouTube channel, which you can find at by searching YouTube for Smitty Halibut, like the fish. We'll make sure to put a link to that in the show notes. And yeah, I mean, this is a project that I'm excited about, but I got to be honest with you, full disclosure, I still haven't ordered mine.
Are you going to be the late adopter?
I am waiting for the last responsible moment.
Come on.
Well, I hope you don't order it when they're out of stock.
That's a good point, right? If we drive so many people there that it's a wait, that's going to be really embarrassing. But no, I have literally, as I mentioned in the last show, somebody asked me if I had been working on the idiot switch that we talked about like way back in episode 9. And I commented this week, I haven't even seen my family in the last 6 weeks, let alone my workbench. So it has not been in the priority, and I take full ownership of that, but things are lightening up for me, and we'll be back fully in the swing of things here shortly. Of course, what I might also do is let everybody else figure out what the coolest possible version of this radio is, and then order it once that's been figured out, and then just build the coolest version.
So what I want to see is how people package them up. So I think we need to do like a beauty contest. Send in the picture of your BIT X40 in the case that you put together for it, and see who did the best job.
Now, Brian, I know we're talking to you about microwave, but have you built one of these radios? Are you familiar with them?
Yes, I have. In fact, when I ordered mine, I ordered 2. So I have one that I actually built at the last minute for Maker Faire, just literally the night before. I'll send you the guys the picture sometime. But I have another one here if you want one.
You have a spare that you want to get rid of?
I have a spare.
Jeremy,
well,
there you go.
Then we'll do that's what
Jeremy.
That's what we do. So, well, Brian, you'll be my parachute. If for some reason they get sold out and I need to get one in time for the show, then I know where to go. That is a very generous offer. Thank you.
Okay.
So, Brian, did you get yours to run as a 40-meter sideband radio by itself or as an IF for the microwave gear?
Well, that's kind of the reason I bought 2. One, to build and get up and running and test it out. And, of course, I packaged it up really nice for Maker Faire. And it worked really great, actually. I was quite amazed that you just, in one evening, just solder things together, get it up and running. I have a long wire just coming into the shack that's not tuned to anything. Plugged it in, and I was hearing all kinds of stuff on 40 meters right away. I was just really blown away by how good this thing is. Tuning is a little strange because they're using a different technique. They're using a pot, a voltage that goes into the Arduino, and they're using that to figure out where to tune it. So, it takes a little getting used to figure out how to tune that. But I think eventually I put in kind of the hooks so that I can hack it and put in a regular rotary encoder at a later time. But we had this thing running at Maker Faire out on the front. I'll talk a little bit more about Maker Faire later, but we had this thing on the front of the table along with an unbuilt one from Dennis, one of our co-exhibitors. And I had my KX3 with the little Arduino gear beaconing in the back. So I had a 40-meter beacon running into a Alex loop antenna made out of copper water pipe, and was beaconing over to the table in the front. And kids would just stop by and be fascinated with it. And they would stay there for 10 or 20 minutes at a time.
So were they fascinated by the fact that it was just wireless in general, or the Morse code, or what was the draw?
Actually, I think the kids were kind of thought the Morse code was pretty cool. They were tuning it around, and they could hear different tones. If you kind of wobble the tuning control, it kind of made music. So it was just more or less kind of a play thing. But some of the kids wandered around to the back to see where the signal was coming from. So yeah, it was fine. I think kids actually still are interested in Morse code. I don't know if you remember, George, but Maker Faire, 2012? Yeah. We had one of your ham stacks with a keyboard, Morse code sender, and kids were fascinated with that. So Yeah, I think if you present it in the right way, kids could get hooked into this pretty quickly.
Well, it's funny how that does have a certain amount of draw. This is a real tangent, but as we got rid of the requirement for Morse code as a hurdle to get your license, you would expect the number of hams using CW would fall off the cliff, but I think it's flat to on the increase. So the intrinsic value of CW is great.
Well, we kept telling the kids they can learn Morse code and they can send messages to each other and their parents wouldn't know what they're talking about.
Always a draw. Well, we'll come back to Maker Faire in a little bit.
So that was thing one, the BitX40. Thing two is we want to congratulate our friend John W7DBO on the launch of the Field Radio podcast, the third show under the Ham Radio 360 banner.
Aren't we supposed to call it a network or something at this point with 3 different shows?
I guess that's true. But Cale always calls it the umbrella.
I know. He doesn't want to be that formal.
But John's first episode just launched, and if you want to know more about this, this show is going to be focused on portable operation, and that could be everything from, grabbing something like the BitX40, getting out and throwing a wire into a tree, all the way to getting into emergency communications and, setting up equipment for that and responding to incidents. But I really like John's premise, which is basically ham radio outside of your house.
Well, and what's going to be really cool is there's a big crossover. I think a lot of our listeners like that as well. And I think a lot of them would like to build stuff. So I think there's a natural crossover between the technical side, the building side that we tend to focus on, and the usage, the application out in the field that John will focus on. Absolutely.
So episode 1 launched on Thursday, of which was yesterday. Wow, that feels like a lifetime ago. So again, we record our show the Friday night before it airs on the Tuesday. And of course, the main Ham Radio 360 podcast airs the Tuesday opposite of our Tuesday. And now Field Radio will drop the Thursday of the same week as the main Ham Radio 360 show, which makes perfect sense in my head. But as I'm saying it out loud, I'm sure I'm being plenty confusing.
So 2 shows one week, 1 show the other week. And if John does an hour show, Cale does an hour show, and our show has never been less than 2. That's 2 hours a week of content. That's actually a lot.
It is, but if you consider the number of regular hosts, that's still an average of an hour of content per host.
True.
Just split it across 3 shows.
There you go.
Although I'm afraid now we're opening the door to, are we too long? But most of our listeners agree we're not. So we appreciate that. Now, most importantly, if you are interested in checking out this awesome new podcast, the format is, I'd say, it's more segmented. It's actually a lot different than either of the 2 shows we have right now. I like it. It's got some funky music. I'm really excited to see what happens over there. And in fact, I actually have some ideas, as John had mentioned, that he has some ideas of some good crossover opportunities. But what you will want to do is go to your favorite podcast player and search for the Field Radio Podcast. You can find more information on hamradio360.com, just up there in the main nav. There is an item that says Field Radio right next to the Workbench. And also, you can follow John and the Field Radio Podcast on Twitter at Field Radio Pod, because apparently there's a character limit to your Twitter handle, which makes sense. I just hadn't thought about that before.
So what's sort of subtle about that is that the Field Radio Podcast is in its own feed. So if you subscribe to Ham Radio 360 today, you get the main HR 360 show, you get the Workbench show in the same feed, but the Field Radio show will not be there. It'll be its own separate feed. So you have to subscribe to that.
We will, of course, include links to all of this in the show notes as usual, which will be accessible on the web or in your podcast player. So definitely go give John, a little bit of your time. Check it out. It's an awesome show with an awesome premise, and I can't wait to see what comes up in future episodes.
So one of the other big things that happened in the last week is we had a chance to chat with our good friend Curtis, K5CLM. And Curtis is the host of Everything Ham Radio. It's a great podcast. You should all subscribe to it. So we had a chance to go on there and chat about the Workbench podcast, talk a little bit about microcontrollers and related stuff, and Hamvention and our experience out in Xenia, Ohio. And Curtis is doing a fine job in zeroing in on episode, I think it's number 77. So he's cranking out the episodes and doing a fine job over there. So congratulations to Curtis, K5CLM, and be sure to check out his show. Also, there's a new microcontroller topic that I want to bring up, Jeremy. I mention it mainly to get people to start looking up information about it. We'll talk more about it on future shows.
So, but before you say anything, I want to point something out. Mm-hmm. So, because I've been busy in the rest of my life forever, I haven't logged into Twitter even in a few weeks. I get on Twitter. I have like 5,000 things I'm tagged in, and 4,722 of them are messages that George has posted about this microcontroller. George has single-handedly spoken more about this microcontroller on Twitter than the entire volume of his previous tweets.
Well, that's because I wanted to send one message that was more than 144 characters, so I had to send it in batches of tweets.
All right. So what is it, George?
This new thing. So of course, what would a show be without talking about a microcontroller? This time, it's not an Arduino. So there's a new board that's available called a microbit. And you can find out more if you go to microbit.org, microbit.org. So what's the big deal? There's a lot of microcontrollers out there. There's a lot of boards and a lot of chips. So why is this all so special? And the answer is that the microbit's a little board about 1.5 inches square, and it's a fairly capable microcontroller. It's an ARM M0 micro with 16K of RAM, 256K of flash, and built into that board is a magnetometer or a compass, a 3-axis accelerometer, a grid of LEDs, a bunch of general-purpose I/O pins, analog to digital converters, and all of that plus a Bluetooth radio, all built in to that little board for $15.
Nope. Wrong.
Nope. Why?
Because of all of your tweeting, I actually picked one up today at my local Micro Center for $13. It was $12.99 or $11.99.
Oh, no kidding.
Yep, and in fact, they have two versions of it, sort of.
No, what'd you find?
So they have the standard microbit, which has everything that you just said, and it basically is the board and a little pamphlet. They had something else. I can't remember the name of it now, and I feel bad, but it was like the microbit something kit. And okay, I'll have to look this up, but basically for $16, you got the microbit, 2 AAA batteries, a battery case that basically took 2 AAA batteries and gave you a USB connector, and then a little USB cable.
Yeah, so that's the thing I was thinking that was like $15. So I guess that's a little bit more for those bits, so to speak. So a quick comparison, by the way. So a quick pause on the hardware. How does this compare to an Arduino? And there's many Arduinos today, so you can't just say, oh, well, here's the exact comparison, unless you pick one. So let's pick the older one that everybody who knows about them knows, which is the Arduino, the Rev 3, Arduino Uno. Quickly, the difference between this one and that one is that's an 8-bit processor. This is a 32-bit processor. Those have maybe a few K of RAM. This is 16K. Those have maybe 32K of flash memory to store your program. This has 256K. The Arduino is just the processor and the USB connection to the PC. This guy has some of the sensors built into it, like the magnetometer and the accelerometer. And this has Bluetooth and the Arduino doesn't. And for what used to be half the price. Now, you can get a cheaper Arduino like the Pro Micro we recommend for our projects that are about $6. But for about twice that price, you get a lot more features. So the really cool thing about this microcontroller is the software environment, because you can program it in different ways. So when you go to the website, you'll see that there's a tag that says Let's Code. And you click on that, and it shows you a couple of options. The first option, you can program it in JavaScript. And JavaScript is a very popular programming language. It's used a lot in web-based applications and in other things as well. And it gives you two ways to actually do JavaScript. There's a graphical programming editor where there's a palette of all of these blocks on the left-hand side of the screen, and you just drag the blocks and snap them together in the display to create your program. And then you press a button on the screen, and it'll toggle back and forth between that block view and the JavaScript text source code view, which is very cool for several reasons. First of all, if you're totally new to programming, it doesn't get any easier than that. Second thing is you can learn JavaScript syntax just by clicking the program together graphically and then look at the JavaScript source. And if you want to edit it, you can modify the JavaScript textually or back in the block editor. So that's very cool. But in addition to JavaScript, it also supports MicroPython, the other super popular programming language. So right now, I'd say the most common languages you tend to find in industry are C, JavaScript, or variations of it, and Python. Of course, there's lots of other languages, but those are super popular. So that's really awesome. When I first looked at it, I thought, well, they're really targeting this towards education. They're really targeting this towards like the middle school student, and they want to make it super approachable. But a lot of times I've talked to many hams who've said, well, I'd love to build a project with a microcontroller, but I don't know how to code. And where do I begin? In fact, Jeremy, remember on the interview with Curtis, he was very interested in doing a project like a temperature sensor and being able to remotely transmit that data. So you could do that project that he was asking about with 2 of these microbits and a temperature sensor chip. So it would be really, really easy to hook it up and really easy to write the software to do that. So it's a really powerful platform, and I was very pleasantly surprised to see that while it's targeting education, it's actually very powerful both from a hardware point of view and the software development tools. So check it out. I can think of several projects that I'd like to do with it already. So I think we'll do a few more projects with this particular microcontroller. So check it out. Go to microbit.org. It's been released in the UK. Originally, this project was driven by the BBC, the British Broadcasting Corporation.
Well, you know that Microbit, if I'm not mistaken, isn't this the second time the BBC has had a thing called the Microbit?
Yeah, the original BBC computer was called, I think it was just the BBC Micro. And that was way back like in the late 70s. So yes, it was back in the old like keyboard computer that would plug into your TV like an Atari or an early Apple kind of Apple II computer back in that era. So yeah, it is. So this is their second go at it, and they've already distributed an enormous number of these things in the UK. Basically every middle school, I think like the equivalent of a 8th grader or so, will be getting one of these boards in the UK. And I saw a press release that I tweeted about that said that the Microbit Foundation's goal is to get 2 million of these boards distributed in the US and Canada by 2020. So I think it's going to be a big deal. It's a great little platform. It's very easy to program, and I think you could do just lots and lots of cool projects with it. Oh, by the way, one other little hardware thing that's pretty neat.
Yes.
On a circuit board, you'll see an edge connector along the edge, right? A bunch of little fingers, and they have that. That's where the general purpose I/O goes. But they did something really odd. They put 5 big, well, in PCB layout terms, we call it a donut. It's a pad with a large hole in the middle. There's 5 of them, about 4 millimeter hole in diameter. And the reason they did that was to allow you to hook up to the board with an alligator clip.
Yeah.
So I thought that was brilliant. So there's a power and ground, and then 3 of the I/O pins go to these big rings. So if you wanted to build just a quick and dirty project, you could just snap in the battery. You can take a temperature sensor with an alligator clip jumper and clip it on and write your little program, and you're up and running. No fancy construction required.
That's really cool. Now, so like I said, I picked one of these up because you were talking about it. I wanted to become conversant on it. And for the price is right. I mean, one of the things that's really interesting in this world is that, okay, so that was like 12 or 13 bucks for that board. Or for $10, I can get an entire 1 gigahertz with a half gig of RAM Linux computer with built-in Wi-Fi. I mean,
Yeah,
the economies at play in these small boards are just fascinating. So my intended use for this, because of the Bluetooth, and hopefully it has a built-in like Bluetooth serial profile, so that I can just use get it to sync with a computer, then use a terminal to log. But I've got a little.
It does. It does. I made a little test project this weekend to do something with that. So yes, it's very easy to do that.
Now, is it 5 volt or 3.3 volt logic?
3.3.
Okay, so I actually have a fairly decent little temperature sensor that's at 3.3 that I picked up for my little Arduino that has Wi-Fi built in. That's based on a SAMD, which is a Core, I think M3, if I'm not mistaken. Much more powerful.
SAMD 21s.
Yep. Mm-hmm. Much more powerful chip, obviously, but also that little Arduino costs like $35 or $40. Anyway, so I'm going to stick this in a room and do temperature logging now that we're in the summer, and we'll see what that's going to be my intended use case for this, is just throw it up there with a battery and just do temperature logging and see what happens.
And if you had two of these things, you could put one in the room to do the temperature sensing and then just have it transmit the temperature data over the Bluetooth radio to the other end. And that data could pop out through the UART and go into a PC.
Well, what I'm hoping is I can just have it connect to the serial, like, again, the Bluetooth serial profile on the PC.
I see what you mean. Possibly. I haven't tried that. But it was pretty easy to establish a connection between the two microbits. In fact, it was trivial. You essentially just say that you want to connect by radio and give it a channel number, and then you can shove data back and forth between the radios, and it just works.
No, another thing that's very interesting about this, I know we're not deep diving on this, and we'll probably do a show, but I noticed that you can actually program these things from an Arduino or an iPhone.
Yes, that's right.
Or not an Arduino, an Android. Right.
Right. So exactly. So the compiler and the editor is also, I think it's written in JavaScript, runs on a web browser, but also there's apps for iOS and Android. So you could not only develop code for it, you could also control things through the Bluetooth connection to the microbit, which is pretty slick. And there's a ton of applications that are already developed. I mean, there's all kinds of little projects that you can find. So this is a case of take something cool and make a million of them, or actually several million of them, and you just know that there's going to be tons of really cool applications that come out of this thing. And it is funny, the economy, like you mentioned, Jeremy, that the fact that you can get a whole Linux computer for less than the price of the microbit. However, depending on your application, one is really better than the other. So if for instance, you said, well, I don't know anything about microcontrollers and Linux and programming, then this microbit would be a way, way better choice, because you don't have to learn a zillion different things that are fairly complicated. You learn just what you need to know to do the application you need to do, and it just works. If you want to do something much more complicated and sophisticated, beyond a microcontroller, then the Raspberry Pi is great. And you can use them together, frankly. You could take one of these microbits and make it a little base station. In fact, that's the application that we worked on this weekend. Was we made a little test case with 4 microbits, sampling data and transmitting it simultaneously to a little base station, a 5th microbit, that would receive the data from each of the units and then pump the data out through a UART pin on the microbit to a serial port on a computer. And all that code took like an hour. I mean, it was that easy. So anyway, very cool. Check it out, microbit.org. You might want to order one to play with it, like Jeremy and myself. And we will definitely have a show on it. Oh, one more thing. I built a project some years ago, about 5-6 years ago, that was a compass for a directional antenna. So the idea was put a microcontroller and a compass chip, a magnetometer, in a box, strap it to the boom of the antenna, rotate the antenna. It would transmit the beam heading to the base station and display it. And that thing cost a couple $100 worth of parts. You could do it with 2 of these microbits for $30. So it's pretty cool.
These are indeed amazing times in which we live.
Indeed. So let's see what else. Real quick comment. We have a upcoming interview with PowerFilm Solar. I know you've used PowerFilm in the past, and they're nice enough to send me a solar panel for me to evaluate and do a review. And I'm sure the review is going to start out by saying this is a really cool solar panel. So that's not the punchline. What I'm really looking for is the practicality of using a folding solar panel, how much power it puts out, how big it is, how do you use it when you're operating portable, that sort of thing. So I'm looking forward to that. And the PowerFilm guys were also kind enough to do a giveaway. So we're going to have them on the show here sometime in the next month. And in the meantime, they have a giveaway happening. So they make these really cool folding solar panels of different sizes. And the perfect size for your SOTA operation for backpack radio would be a 30-watt panel. So they are sponsoring a giveaway. And if you go to a website that I will tell you in a moment, you can go there and sign up. And in a month, we'll do a drawing, and one of our lucky listeners will get themselves a 30-watt folding PowerFilm solar panel. So the place you want to go to sign up for this is www.powerfilmsolar.com/products/workbench. And that, of course, will be in the show notes. So www.powerfilmsolar.com/products/workbench. Sign up with your name and call sign, and you'll be in the drawing to win the cool solar panel. So thanks very much to our friends over at PowerFilm for doing that, and I look forward to us chatting with them when they come on the show.
That is awesome. I've had a bit of a relationship with them for several years. Love their products, and then, like I said, we just ran our entire field day off of them just for field day this year, and I did that back in 2014 as well.
How many panels did you use at field day?
Both times I have 220-watt panels, so I used both of them, which is way overkill. In neither field day was I ever really taxing the panels, because in the QRP field day that we just did, obviously power was being sipped the entire time. But honestly, even with the QRO field day that I had done previously, where it was basically one 100-watt radio and a 20-watt radio being run off of it, we weren't really using the panels to their full capacity, except on the Sunday morning, right? Because if you've been using your batteries all night, then the order of the day is to crank and get as much energy that you actually depleted overnight back in. But yeah, phenomenal products, very easy to work with. I can't wait for that episode, because I have a lot of experience with this, and am very, very much a fan of their products.
So that'll be really fun to have them on, and some lucky listener is going to get a really cool solar panel for their SOTA gear. So one other thing I want to mention before I'm done in the beginning here is I did a Autodesk Eagle webcast about a week ago, and the Autodesk folks invited me to talk about some of our build projects. And so the one that I picked is our power monitor. So we did about an hour webcast, and it's recorded, and you could take a look at it offline. It's on YouTube, and there'll be a link in the show notes. So we talk about the application of the power management board, what it does, why you would want one, and I walk the viewer through the design. So we look at the flow of the circuit, we look at the circuit board layout, and we talk about some of the techniques for doing board design. So if you are interested in seeing how Eagle works and would like to see a little bit more about the power management board we designed, you could check out the Autodesk Eagle webcast on YouTube. If you just go to YouTube, you could find it by searching the keywords Eagle Power Management. So Eagle Power Management will take you right to it, and hope you enjoy it. So Jeremy, what's on your workbench?
Well, as I mentioned, I haven't really seen it in a long time. Normally I say that because of all the clutter on it, but I've been pretty busy. I honestly, the biggest thing I've been doing, I answered this on Curtis's show. I think I talked about it in our last episode or two here. I've been obsessed with finding the ultimate ham radio laptop. And I have said previously, there is a little device, the Asus T102 Hotel Alpha. It is an Atom-based quad-core 4 gigs of RAM, 64 or 128 gigs of eMMC storage. It's a tablet with a like magnetic foldable keyboard. And it's just about perfect. I actually ran into the first and only problem that I have with it. When I say perfect, I mean for ham radio applications. So what does that mean? That means running maybe RT Systems programming software or Chirp. It means running a logging application like the N3FJP or N1MM. It means running like the suite of FL Digi products or DRATs or any of these like special purpose built WinLink applications that require Windows. It even means running SDR Sharp with something like an AirSpy or an RTL SDR dongle. But I ran into an issue where I got my AirSpy R2 2 weekends ago at this point. Of course, that SDR is a 10 megahertz of bandwidth. The sampling rate on the USB bus is, which I realize is the same thing as saying pin number. But the speed of the device is 10 megasamples per second. And on this machine, I tried everything. I tried new USB drivers. I tried old USB drivers. I tried munging with power settings. I did everything I could think of, but I could not reliably get the full 10 megasamples per second coming out of the AirSpy R2 and getting into the software. I was getting audio was going like like stuttering or doubling, where it sounded like if you had the audio source going into a recording and then like an open mic in a room playing the same content over a speaker. It works fine with the AirSpy Mini at 6 megahertz of bandwidth. Absolutely works perfectly. Works fine with the R2 at 2 megahertz of bandwidth. There's one thing that I haven't tried, and that's upping the priority of SDR Sharp to see if maybe that would help. But otherwise, I think this thing is just about darn perfect. So much so that I actually returned it and then ended up going back and buying the one that I returned again.
So you returned which one?
So last time we talked about this, I had an HP Spectre 12-inch that had a Core M3.
Right. That was the fancier one.
That was the fancier one. I returned it. I kept the Asus. When I got the AirSpy R2, I tried everything to get it to work, and I realized, well, for what I really want, which is also the ability to do portable SDR stuff, I need more power. I ended up buying an HP NV13, which has a 7th generation Core i5, 8 gigs of RAM, and a 256 gig NVMe solid state drive. Really snappy machine. It's like an $800 machine. I got it for $550 as an open box, which is the only reason I was able to afford that. It's great, and that'll like actually end up now being my like portable podcast producing laptop. It actually is powerful enough I can do video editing on it.
Oh, nice.
But that's kind of a cheater, right? Because I had that, and I had actually returned the Asus to get that, and I was like, okay, now here's SDR Sharp, and all SDR applications I want to do now run flawlessly. But I was missing that little 10-inch Asus tablet because so I ended up going back, and they hadn't sold the one that I returned yet, and so I ended up buying it back, which at the end of the day, here's the summation of all of this. And as far as what I think a perfect ham radio machine is.
Okay.
And in this particular case, it's rechargeable via USB. And in my case, that means regular plain old 5-volt USB up to 2.5 amps. Or in the case of the Spectre or a lot of other more, like almost all of HP's higher end machines with USB-C connectors, almost all of them, especially at this point, support USB-C power delivery. And there are a few vendors starting to come out with 12-volt to USB-C power delivery adapters. So that to me is important because A, you're not lugging around weird adapters to go from 12 volts to 19 volts, and then you fool with like, the removable tips, and you got to get all that right. And chances are there's a lot of RFI with the adapter, etc. And the ones that I have found that work really well and are RF quiet, they were Radio Shack closeouts, right? Like you'll never be able to find those again unless they're used. So the USB recharging is key because it's easy, it's fewer steps, an inverter's not involved, etc. 2 is a brilliantly bright display. The Asus tablet is rated at 400 nits, which is stupid bright. The Spectre X2 that I had was rated at like 300. And just to give you an idea of what this meant, it meant that the Spectre at 100% brightness was still only what matched the Asus at 50% brightness. The brightness outside of field day, never had to shade my screen, didn't have to build a little hood for it. It was phenomenal. And the next thing after super bright display is 4 gigs of RAM. I have purchased like the $99 2 gig, 32 gig of storage, like Windows tablets before for this purpose. And they're kind of functional. Like for FL Digi and you want something you can throw away around in your backpack, you don't care what's going to happen to it. It's USB chargeable, probably not that bright, but again, it was $99, so who cares? The 4 gigs of RAM, especially with an Atom CPU, makes a world of difference. So I think 4 gigs of RAM on this modern machine is a minimum. Finally, if you're going to do SDR stuff, having a fast USB bus, which I don't know how you tell that. The Atom's probably, just the platform probably is not right for you. Real quickly, we're talking about Atoms, but one of the things I learned on this journey is, are you familiar with what effectively the promotion path through Intel CPUs is from worst to best?
Just vaguely.
I mean, so one of the things, especially on these lower end machines, everybody I think knows what like a Core i3, i5, i7 are. Those are the premium citizens in the Intel family world. But you hear about Atoms, you still hear about Pentiums and Celerons. And it took me a little while to figure this out. So basically an Atom is their lowest performance processors. They're designed to be system on a chip, competitors to things like the Broadcom CPUs in a Raspberry Pi, right? They're meant to be an all-in-one system on a chip, incredibly low power for embedded applications that require a lot of efficiency and require or don't require active cooling, basically. So to move up from an Atom, then you get into the Celeron land, and they're just, again, lower end CPUs, fewer features, etc. Still power efficient, but they have more power than Atoms. From Celeron, you go into Pentium, same kind of stepwise performance, etc. From Pentium, you could debate whether you jump into the Core i3s versus the Core M3s. So the Core M are CPUs that actually perform pretty close to the Core I series, but they're incredibly power efficient and also are designed to not require active cooling. They're
well, the M. Go ahead.
I mean, I'm going to say that. I mean, they're. Well, now you made me forget what I was going to say. What were you going to say?
Oh, I was going to say the M is mobile. It's really they're targeting laptops largely.
Yep, and pretty much I think the biggest introduction of these commercially was the MacBook, which is the impossibly thin, lowest end Apple portable computer. At this point, they've been used in like the Surface 3 and the Surface 4, the HP Spectre X or Spectre X2 12-inch tablet I was mentioning was available with one. There are several computers that use the M series processor. There's an M3, an M5, and an M7. Again, if you do performance comparisons, they're not terribly far off from their I series counterparts, but they're a lot more power efficient and they stay a lot cooler. So I think generally speaking, even if you get up to a Pentium, like start at a Pentium, I think that's probably plenty of performance for something we're using to program radios, run some digital mode software, or even running, full-featured software-defined radio software like SDR Sharp. I mean, again, the Atom is enough for almost all that stuff. But I think those are the characteristics of like the ideal portable laptop. And again, the Asus almost hits everything perfectly for me, except for it wasn't able to run the full 10 megasamples off the AirSpy. But I can live. But it's actually been kind of fun going through all this because I've been out of the PC world for so long. I've been a Mac user for so long. I didn't have any of this knowledge, and I'm coming away a better laptop consumer, at least for this generation.
There's portability, low power consumption, running applications that are pretty static and simple. In the ham world, that might be like an FL Digi or a logging program. Or there's applications that are more compute intensive, and I guess I'd put the SDR application kind of almost in the middle. It's not super compute intensive, but it's not might be a little bit of a stretch for a lower end machine. So
well, I mean, it's the data bandwidth, right? Because when I run it, SDR Sharp with the AirSpy Mini at 6 megahertz is only pegging the CPU at like 38% on the Atom. Mm-hmm. So I mean, it's not using a ton of memory or clock cycles. I think it really is just the bandwidth of data going over the bus to get to it is the issue.
So at the end of the day, what did you boil down to as your favorite laptop? Was the answer both?
Well, I mean, it is, right? Because I kept both, right? Like there was actually even a model of this scenario where I was like, you know what? I'm going to keep both tablets. Because now, so the NV13 that I wound up with was kind of like a mid-cycle refresh. So it has like the latest generation Kaby Lake processor. It has a USB-C connector, but it does not seem to support power distribution or charging over USB-C. And I'm not brave enough to hook my USB-C charger into it to see what would happen. But no, at the end of the day, that little Asus, like the idea of ever taking my KX3 out to the field again and not having that little Asus tablet like I did at Field Day almost made me cry. Like in the way that if this were Saturday Night Live, there'd be a montage of me like sitting in a park on a blanket, like petting it, and then us running through a field together. You know, like
while the music swells to a crescendo.
Yep, and like it would show when I returned it, it would show me crying as I walked away from Micro Center, and it would show it crying as it was being carried back to, be wiped by the technician and put away back on the shelf. So at the end of the day, I went back. I kept the Asus T102HA. I think it is, for me, it does everything in ham radio I want it to do. And I'm going to be honest, I don't want it to run Ham Radio Deluxe. Ham Radio Deluxe at this point, I think, is served best by having 15 monitors that are capable of like 8K Ultra HD. I have no interest in that. For digital modes, programming, running D-Star software, actually running my hotspot off of it, my little DV Mega hotspot off of it is awesome. So in every other conceivable way, it's perfect. Super bright screen, rechargeable via USB, and RF quiet. I can't ask for anything more. The good news is these things are kind of still available out there. I actually tweeted a link to one on the Microsoft Store, which is on sale for like $250 with the 64 gigs of storage. But I think Asus is refreshing this model to the T103HA this year. It's going to still be $400, and you're going to lose the pen that it comes with, but what you are going to pick up is an internal LTE modem. And I can only imagine, like 3 years from now, like what for the same money you're going to be able to get in a tablet form factor. I mean, it's really fantastic. If opportunity presents itself, I plan on doing a video review of the application of this thing in ham radio.
That's a great idea. I think you should do that.
What's on your Workbench?
Nothing's really changed that much on my Workbench. I have a bunch of unbuilt kits. My Whisper transmitter, my BitX. I'm noodling over the Go box and trying to figure out the best design for that. I decided after Field Day, this is not exactly what's on the Workbench, but what's occupying some of my thinking is I'm going to cull the herd. I'm going to reduce the number of radios I have and go deeper in understanding how each of them work much better. So less stuff, takes up less space, and try to be a little bit more expert at using what I got. So I haven't quite decided what that's going to ultimately be. So that's kind of work in process. I did pick up one cool radio used. I had no expectation of looking for this thing, but in the process of trying to sell a bunch of radios on eBay, I accidentally tripped across a used.
You're doing it wrong. You went to go. You came home with more radios than you tried to sell. Okay, go ahead.
Kinda, yeah. That's kind of how it works, So I did wind up buying a Kenwood TR751A. Do you know what that is? It's an old radio.
It sounds
so.
Old.
This thing, it is. These things were made about 30 years ago, and it's a mobile radio. It's about 7-8 inches wide, about 2.5-3 inches tall, and about 9 inches deep. So it's kind of big. 2 meter only, black radio, and it is a all mode 2 meter radio. So I didn't get it for FM because I've got way better FM radios now. but I got it because it does 2-meter single sideband and CW, and it's in awfully good shape. It's like perfect condition, and it just arrived, and I put it on the bench, and it puts out 20 watts, which is the rated spec, so that's awesome. And I got on 2-meter sideband last night and was chatting with about half a dozen other guys. So the thing works. And the reason I remembered this radio is that it has a gas-FET front end. So it's got a very sensitive receiver. So they make for a pretty good all-mode radio. You can buy them pretty much on the cheap on eBay relative to a new radio. So I thought I'd give it a try, and this one looks like it's a winner. So mainly I got it for our field day 2-meter sideband station. So rather than burn up a expensive multi-band radio for 2 meters, I thought this would be kind of a good 2-meter station for that.
Well, cool.
Yeah. So looking forward to playing with that a little bit more. It'll probably live on the bench or the desk for a while before it goes into some case or another for field day. So that's kind of it. So with that, I think it's time to bring Brian into the show. We have a quick word, and then we'll be right back. Elecraft is one of my top picks for high-performance HF radios. They make fantastic base station-style radios, amplifiers, pan adapters, and other station accessories. They're also the designers of the KX3 and KX2, the ultimate portable HF radios. If you're thinking about SOTA, portable operating, or travel, you really need to be looking at Elecraft. Elecraft has some of the best designs in the industry, compact, high-performance, feature-rich designs. You're really going to love them. And Cale just got his KX2. So be checking out the Ham Radio 360 podcast and also the Facebook page and see what he's doing with his KX2 radio. The KX2 is my personal favorite for going portable. It's ultra small, 80 through 10 meters, sideband CW and data modes, and the thing runs 10 watts on the internal batteries. You'll love it. Check it out at elecraft.com. So on today's show, we have Brian, W6BY, and Brian said hello at the very beginning, but welcome back, Brian.
Hey, thanks, George. Glad to be on your show.
And we've really wanted to get you on here, and I want to tell you guys a little bit about Brian before we start on microwave radio. His background is from the computer industry. Brian started out working at IBM on mainframe computers, did that for several years, and over time eventually migrated over into RF design and has worked for various companies doing RF-related activities. The most recent thing he was doing was working for Google on a very interesting project, and hopefully he could tell us a little bit about his experience at Google. And then Brian retired. But as with a lot of folks these days, that didn't last long. I think you were retired for 6 months and then came out of retirement and is now working full-time for a electronics and a technology company doing digital signal processing engineering work. So Brian's got a really great background on the professional side. And on the ham side, Brian is an expert at microwave radio. So when we talk about microwave radio, we talk about stuff that's up above a couple of gigahertz. And I know a lot of people listening are thinking, well, does anybody use that? And it turns out that there's actually quite a few people who do microwave radio, and Brian's an expert at that. So we wanted to get you on the show tonight and tell us a little bit about that and what that world is all about, and can regular people actually do microwave radio. So welcome to the show.
Thanks, George. I am very humbled by that beautiful introduction.
Well, it's all true as far as I know. So you shouldn't be embarrassed by that. So,
yeah.
So Brian, so you and I have something in common. So we both belong to the same club, which is part of the way we got to know each other. So you and I are both members of the Cactus Intertie, which is a big linked repeater network. And there's a lot of guys in Cactus who are big in the microwave world. So we'll talk a little bit more about that. But before we dive into all that, let's wrap up the Workbench topic. And Brian, tell us, what do you have on your Workbench right now?
Oh, on my Workbench. Now, I remember you talking to Jeremy about the TR-751. Well, I just sold my one TR-751 to a coworker to get him on the air on microwave. So
very good.
We'll talk about that as a good microwave rig further down the line here. Other than that, a few weeks ago, couple of us were at Maker Faire, and I built at the very last minute a BitX40, and I actually put it in a really nice case, and that was a really popular thing at the show. So, we've talked a lot about the Bit40. I think it's a great rig to get people started. Other things on my workbench, I'm in the process of building a cobweb antenna and actually proving out the balun that was on the website of, I forget what it's called, it's G3 something or other. You guys know who he is. And so I'll put that up maybe this weekend, hopefully. Other than that, I've got a design going for 15 gigahertz, 10 megahertz to 15 gigahertz microwave PLL board using an LMX2594 chip from TI. That is a really amazing thing that we can get a synthesizer that goes over that range. I wouldn't call it a few bucks. It's a fairly expensive chip, but what used to be a whole box full of parts is now just one chip. So that's one thing that's on my bench. Always gathering parts for microwave beacons. I'll talk about those in a little bit and why we need them and what they're for. I've got acquired on eBay an old Tektronix 576 curve tracer, and it came to me kind of in a fixer-upper condition. I started fooling around with it on the workbench, and after a few minutes, black smoke started pouring out the back. So I shut it down really quickly, and I've got to do a bit of work back there. What else? Oh, a few weeks ago, I was up at a repeater site, and there was this preamp that was smoked for some reason. So I've got that on my workbench, kind of in the queue to get fixed. So
is that a preamp that I'm personally familiar with?
Yeah. It's what they call blackened preamps.
Yeah.
So, yeah. I think there's some hope for it. I'll get to work on it. Finally, a couple days ago, I got a new toy, an SDR Play. So I've been messing around with that and comparing it with my, what's the other one? The Hack RF. I'll probably do some real radio tests on each of them. So far, actually, I like the SDR Play better in terms of sensitivity. So, but of course, the Hack RF has got more frequency range. And as I'll mention a little later, it can be used for microwave stuff too. So that's pretty much it. My workbench happens to be one of those things that's like first in, last out. It's kind of context sensitive. So whatever's on top of the pile is what I worked on last. So I can always find something. If I really get disciplined and clean up my lab and put everything away, I can't find anything for months. So I usually leave it in a state of disarray.
Well, judging by the picture of your workbench that I saw, you have a lot going on. You've got a lot of things in flight at one time. Yeah.
Well, the only problem with that is the more stuff you have, the more stuff you have to fix. So,
yeah. That's, well, if you like to build stuff and fix stuff, this is the hobby for you. So, Brian, why don't you give us a little background on yourself, how you got interested in microwave radio, and what is it about that you find so interesting?
Okay, sure. Let me kind of backtrack, and like my interest in electronics in general started in my younger years when I was a small child. My parents gave me a crystal set, and I built that, and I started playing with radios in the house. At that time, they were all tube radios, and I would be poking around in them, and suddenly there would be a bright flash, and the house would go quiet, and I'd run downstairs quickly and flip the circuit breaker back on, which led me to, getting some classes in high school in electronics, and also getting my first hand license in 1968 as a novice. So quite a few years later, after upgrading my ham license and doing a bunch of other things, the usual repeater thing, HF and so forth, I met some friends, or actually knew some friends in a ham club, and a bunch of us got together and we wanted to go backpacking. So we were kind of combining ham radio with backpacking. This is way before the SOTA stuff. And we take a 2-meter rig, battery rig, a pole, antenna, and we go up in the mountains, somewhere, some hilltop, put all this stuff together, have lunch, get on the air, and call CQ on 2-meter sideband. And it's amazing how many people are out there. So that led to doing a little more activity on the VHF stuff, getting in VHF contests. Well, it turns out that in a lot of VHF contests, you get multiplier points for, higher bands, or the more bands you have. So we decided to build some microwave, what we call transverters, and I'll explain what that is in a minute. So we were, in addition to the VHF, UHF stuff, we were doing microwave, and I started building stuff for higher and higher bands. And eventually I heard about this thing called the 10 gig contest. So I built a 10 gig rig. Probably took me a week and a half to build, kind of off and on. No rig is good until it's built the night before, right? So I got it on the air and went out, and I had no clue how the contest was run or anything. I went to a whole bunch of different places, long drives to the wrong places, and then somebody told me on the radio about this thing called Cactus. I said, "What's that?" "Oh, it's this repeater system. That's where all the microwavers are on." So they told me what frequency to get on and how to do it. And as soon as I got on, I was a new call because all these guys kind of knew each other. And pretty soon I had a pileup. So that was pretty exciting. That was my first time out, and I had all these guys to talk to on 10 gigs. So that is kind of what, got my juices going and got the bug. So I've been doing this ever since.
So how long ago was that you started into this?
Oh, man. This was about 1990, 1991. So I've been at this for, 27 years? A long time. A lot has changed since I started, too.
And I bet in that time, you've probably built lots and lots of different radios.
Yeah, I have probably built 8 or 10 transverters in that time. Some of them work okay. Some of them work pretty well. Some of them did not, but that's the way it goes. You try experimenting with different ideas, and some of them sometimes don't work out. So you just tear it apart and start all over again.
So what was the highest frequency radio you've made so far?
Highest frequency was 47 gigahertz. So that, as you go higher in frequency, there are fewer and fewer people to talk to. And it gets actually harder because your amount of power that you can get out of a rig goes down. So most of my activity is on 10 and 24 gigahertz. And the reason for that is the August-September 10 gigahertz contest is kind of the big one. And most of the guys have 10 gigahertz only rigs, but with the availability of parts and advancement in technology, a lot more material is starting to come onto the market, surplus or new, at 24 gigahertz. So 24 gigahertz is definitely more challenging, but certainly doable now. And what I've done was built, in order to not carry around multiple rigs, I built what they call a dual band rig, which is 10 and 24 gigahertz all in one box. And that also combines 10 and 24 gigahertz into the antenna feed. So, that's a very competition grade rig, relatively high powered compared to most. Pretty good sized antenna, very sensitive receiver. And I've so far done pretty well in the contests. I've been in the top 10 every year, for about 4 or 5 years, I guess.
Oh, wow. Congratulations.
Yeah.
So I want to come back to a couple of points that you mentioned there a bit later. I want to come back to what exactly goes into making a microwave radio, and also how do you operate? Because I don't know if you just sit at home and try to CQ, or if you, when you're working the contest, or you get out and operate portable. We'll come to all that in a little bit, but for a little more background, so when we say microwave bands, what frequency bands are we typically talking about? You mentioned 24 and 40, or 10 and 47 gigahertz. Are those the most popular microwave ham bands?
Yeah, at this time, 10 and 24 are the most popular, because the 10 gig, the August and September contest is the one with probably the most participants, and it's 10 gigahertz and up. There are other contests at lower bands. So just for background, we have bands at, I call microwave anything above, say, about a gigahertz or close to a gigahertz. So, 900 megahertz kind of quasi qualifies as microwave. Basically, if you build a circuit, it starts to become more like microstrip, or things that you don't do with just, winding an inductor or regular capacitors. Now you're starting to be able to do things on a circuit board and have a tuned circuit, rather than just winding inductors and stuff like that.
So in that case, what you're talking about is when you draw a trace on a circuit board, that trace becomes a component. It's not just an interconnection between two parts. So now you've got a capacitor or an inductor or something, because you have a trace there.
Yeah, I mean, you can make a capacitor out of a little square PC board on your PC board, and every little thing starts to count now. A little stub here and there, and a trace of a particular width and a length becomes now a transmission line, and so on. And we also have, going up in frequency, 1.2 gigahertz, which is a fairly popular band, especially among EME guys. And I'll talk about moon bounce. I'll talk about that in a little bit. Going up, we have a pretty good chunk of the 2 gig band. So 2304 is a semi-microwave band used for weak signal work. So, for example, if you're going to do moon bounce, you'd probably be there. We also share a piece of the Wi-Fi band, the lower end of the Wi-Fi band. So if you want to run a little more power on your Wi-Fi, obviously you can't, on these ISM or ham bands, you can't do stuff that you would in your ISM kind of radios, like, encryption and stuff like that. You can't run a VPN legally and stuff like that. So there are some limitations, but there are also some advantages. And we also we have a 3 gig band, 3.4 gigahertz. We have portions below the 5.7 gigahertz Wi-Fi band. We have 10 gigahertz, 24 gigahertz, and on and on. So if you add it all up, we've got about 20 gigahertz of radio space to play with. And to be honest with you, most of the time we're not using it. It's empty. For the weak signal guys, think about a band that's 500 megahertz or a couple gigahertz wide, and we're doing narrowband work at 3 kilohertz sideband. So we're wasting a lot of it. For guys who want to get into it and experiment with, say, wideband digital modes and other things, there's this huge playground that's available to us. So, I mean, for the guys who want to do something a little heavier technically, it's a good place to be.
So I'm going to come to the practicality of someone actually building or operating radios in that spectrum in a little bit. So one thing I wanted to mention while we're on the frequency topic is that I always would think anything above a few gigahertz is just super exotic, and you have to be a microwave expert, and there's not much up there except maybe some satellite stuff or radars. And in the commercial world, there's a lot of activity right now around the next generation cellular standard, which is being called 5G, of course. And 5G, while it's still out in the future a bit, it's probably not going to be here for another couple of years at least. But some of that spectrum at the upper end of what you're just talking about is going to be used for 5G up around 65 to 85 gigahertz. And there's other companies that are, various companies are experimenting with other segments of the microwave band, like 26 gigs and other places. So that space that was really just for a precious few is going to be prime real estate, not only for cellular, but for automotive radars and other applications where very high bandwidth is going to be necessary, and short range is reasonable for the application. So that spectrum is going to become quite valuable, I think, in the next decade.
That is true. And there's always the possibility of us having a conflict up there. But at the moment, the way the band plans are laid out, for example, right now there's car radios. They took part of our band away for 76 gigahertz car radios. But we still have up to, I think, 81 gigahertz. So, yeah, okay, they took a piece of it away. But a lot of guys moved up in frequency because there's this thing called atmospheric or oxygen absorption, which causes some bands to be highly attenuated, which is exactly where the ISM bands tend to be, because they tend to be short range. So it just so happens that where there's more or less a null in that oxygen absorption band tends to fall into our ham band, and a lot of guys are using 80 gigahertz instead of 76 gigahertz that we used to have. So, there's pros and cons there. I mean, yeah, sure, there's pieces of our band that are going to be looked at by commercial interests, and they want to grab some stuff away. But on the other hand, it does open an opportunity for us getting more parts and components cheaply. So, when you start an industry where people are building things by the millions, all of a sudden the prices of things that used to be expensive now drop to where we can afford them. Or maybe you can buy an entire radio for a lot less money. A lot of guys, there was one company that had surplus millimeter wave links at 80 gigahertz, and a bunch of those came on the market, and some of our guys snapped them up, and they're doing stuff, communications at 80 gigahertz using repurposed microwave links. So yeah, I'm not terribly concerned that commercial interests want to share our bands, and we can coexist if we do it properly.
So one of the things that's exciting about this space is pointing out maybe the obvious, and that's that anybody with an amateur license could operate in the microwave bands, because a technician has access to 10 meters and up. So you've got full access to all of the bands and all of the ways we're talking about using it. So there's no restriction for a technician, right?
That is correct. And that's one of the great things about kind of the no-code license, is that it opened the door for a lot of guys who held back because of the code requirement are now getting interested in this kind of stuff. We have a bunch of guys in our microwave club that are technicians or have kind of re-entered the ham radio hobby just because of doing something interesting in microwave, and also because there's no code. So yeah, I think it's a great thing. And you don't have to be a radio genius or a radio engineer to get into this. We have a bunch of guys. I'm thinking of Marty, who happens to be an accountant. I have a friend, Steve, KB8BAO. He's not an engineer. I think he's got a business degree or something like that. And he's done stuff all the way up to 47 gigahertz. And you can buy basically pre-built kits that, you don't have to assemble all the surface mount parts and do have a whole lab full of microwave gear to get on the air. You can actually buy some kits, and it's not exactly like plug and play. You kind of have to, wire a few things together. But it's kind of like your BitX40. It's a module that's ready to go, and you can kind of customize it any way you want. So kind of a very similar concept.
So in a little bit, I want to dig into some specific examples of how you could build up your own microwave radio. But before we get there, can you describe a bit about what people do in the microwave bands? Because I could certainly imagine that you might do some experimentation where you build a receiver and a transmitter and you talk across your garage or something like that. But there must be something beyond that. So how do people actually use these bands?
Okay, well, I guess you would kind of break it down into kind of like subgroups. There are the guys that kind of experiment. They never really get on the air, but they buy microwave parts and they kind of fool around in the garage or the workshop and just shoot signals across the room and experiment and just learn about microwaves. They don't really do much with it. Then there's the kind of casual guys who build a kit or maybe buy a used one from somebody, and they may get on once in a while. They just kind of dabble and when there's a microwave outing, they may or may not get on the air, or they might just come to the club and listen and learn. Then there's the guys who are a little bit more serious, the contesters like me who build a radio and get out for the contest. I have to admit, I'm actually not so much on the radio, on the air so much. I'm usually listening. I'll listen to the repeat. I'm not terribly a repeater guy. I'm mostly listening, and I'll just tune around HF. I don't get on the air that much, but I listen a lot. But I also like to tinker and build and so forth. That's more of a thrill for me. So being on microwave gives somebody who's kind of that technical bent to give them something challenging and build something on the bench and actually see it work. And then after the contest is over, you put it away for a year and go back to tinkering again. So, there's that class of person. And then at I would call the elite class of people are the guys who do the more exotic stuff like moon bounce, otherwise known as EME. Those guys will build massive antennas, dish positioners, moon trackers, really big amplifiers and ultra low noise, super sensitive receivers, and they'll get on at various times of the year and try to stretch the limits of how weak of a signal or how high in frequency you can go. I think the record right now is at 47 gigahertz, Earth to moon to Earth, and a couple of guys are working on 76 gigahertz or 80 gigahertz moon bounce. So one guy in Texas, a guy in Canada, and a guy in Russia, and we have one guy out here who's all working on it. That's pretty crazy.
How much power would they be running to do something like that?
So power way up in those frequencies, 80 gigahertz. This Russian guy, I don't know who he works for, but he managed to get a hold of a 200-watt amplifier. Wow. At 80 gigahertz, that's really amazing. Most of the time, you'd be lucky to get, say, a watt. So
maybe there's an aircraft carrier that's missing a radar or something at this point.
I once heard a story of a guy who found a 47 gigahertz amplifier, and it wasn't very long afterwards that somebody came knocking on his door to ask him where he got that, because it wasn't supposed to be, let's say, out on the open market.
So my personal brush with microwave operating came listening on the Cactus Intertie, as you mentioned before, because during those two big contests, the Intertie is a set of interconnected repeaters across the whole southwestern United States, and when you listen over the contest weekend, you hear nothing but people trying to coordinate microwave shots across ridiculous distances. So yes. It's very exciting. I mean, I had zero interest in microwave radio, and I'm listening to all these guys trying to coordinate microwave shots like hundreds of miles away, and I'm thinking, man, that sounds like a lot of fun. They're having a great time. So it's very exciting. So could you describe how that contest works, and what kind of distances and what bands are normally used, and what modes are used?
Yeah, so this is one of the big things that drives us techno geeks is we do a lot of very weak signal work. We're trying to push the limits of distance, frequency, all kinds of things. So the further away you are, the more points you get in the contest. So the contest is scored by of obviously number of contacts, the distance that you work somebody, the frequency band that you are working them on. You get multipliers the higher up in frequency you go. So, 24 gigahertz is like, twice as many points as 10 gigahertz or something like that. The number of unique calls, so as many stations as you can work, and some other factors. So that's kind of what, makes this contest a lot of fun.
What really sort of blew my mind, by the way, was that this was not like two guys talking across the block. I mean, this is not like a 2-mile contact. They're going hundreds of miles.
Yes. The other one thing that's different about this microwave contest too is that, in HF contests you're not really allowed to prearrange calls. On microwave contests, it's exactly the opposite. You are actually encouraged to set up contacts ahead of time just because of the distances and the kind of, directionality of these dishes. So let me explain that, there are several factors that make for a successful contact. You have to worry about time. That is, if you're transmitting and nobody's listening, you're not going to make a contact. So being on, who's listening and who's transmitting is very important. Direction, that's very important because the antennas that we're using are dish antennas, and typically they're maybe 1 or 2 degree beam width and about 30 dB of gain. Can you imagine doing that with your HF antenna? Wouldn't that be great? And the other thing is frequency. So if two guys are pointed at each other and they're talking at the same time, it doesn't matter if they're not on frequency. So frequency, time, and direction. So thereby comes the importance of having some kind of really good liaison. One other thing I forgot was the path. So having a good path, because there is propagation on microwave and millimeter waves. So those 4 factors necessitate having some way of communicating with each other and setting up the contact, telling the guy kind of where you're at, what time you're going to be on, being on frequency and all that stuff. So what tends to happen is in different areas of the country, because other areas of the country may not have the cactus repeaters, they're just ground to ground, everybody kind of has to develop a different strategy. So, for example, the guys on the Great Lakes on the East Coast all communicate by 2-meter rigs, and they all pick a frequency and call each other on that. Out in California, we're lucky to have a repeater system to talk over, which spreads pretty much from Northern California all the way down into Texas and Arizona, and guys set up their contacts that way. So I don't know if the guys have heard about the Cactus Network, but it's a whole network of linked repeaters that basically are full duplex. So during a contest, everybody's getting on, setting up contacts, and hollering over at each other, talking over each other and everything. It's for the novice to the contest, it sounds like complete chaos.
It sounds like a lot of fun, actually.
It is.
So I think that that coordination is really necessary because you'll talk about it in a bit. Is I guess the antennas are very directional. So if the beam width is really narrow, you could be off 10 degrees and not hear the other station, maybe.
Yes, especially if you're looking for a weak signal. Just bumping your dish a little bit cause the signal to either be there or not be there. There's been occasions where I've been listening, trying to hear somebody, and I look at my compass and it's off by maybe a couple of degrees, and I just tip the dish a little bit, and all of a sudden the guy jumps out and he's like S9.
Wow, so, that's a huge difference. So what kind of distances have you seen? What's the longest distance you've heard a contact made in the contest?
I'd have to pull up the record book, but It's something like 1,100 or something kilometers, over 1,100 kilometers. I think it's kind of been a contest between North America, Europe, and Australia. I think the record right now, I don't know if it's the French or the Australians that have the distance record on 10 gigahertz, but it's basically the distance is all the way across the Australian continent. So they were doing that over water from kind of the tip of Australia to the other lower tip of Australia. If you look at a map of Australia, it's kind of like an upside down horseshoe.
So are these contacts essentially line of sight, or is there? I mean, obviously there's no ionospheric propagation.
Oh, no, that's not true. So a lot of these long distance contacts are done non-line of sight, and we take advantage of different atmospheric conditions, which we call tropo. Tropo happens when you get different temperature gradients in the atmosphere, and what it does is actually form a sandwich of warm air and cold air, and thus forms this kind of a waveguide. If you happen to have that, if you're lucky enough to have that happen in the direction you're pointing, you can go hundreds of miles, and the signal will be just amazingly loud. We actually experience that pretty much regularly out here in California in September and October, right around sunset. We have signals that you during the day couldn't hear, but right around sunset, it jumps 20 over 9. It's
Wow.
really amazing. And then after the sun goes down, it's almost, I guess, kind of like the gray line. And after that, it goes away.
So you have a window of an hour or so where you might be able to get some really awesome contacts.
Yes, that's when pretty much all the records have been set during those band opening or band conditions. I've experienced it even at 24 gigahertz.
So now when you're trying to work a really long distance like that, are you doing this from the top of a mountain, or are you doing this on the ground?
Well, there are various kind of modes that guys do. In general, in the past, guys tended to go to mountaintops because, you go to a mountaintop, you've got a clear path. Things were line of sight back then. As rigs have improved, better ICs have come on the market, better transverters have been built, much more sensitive, better antennas, better feeds. Guys now also do things like roving. They do house to house. Of course, the Earth, Moon, Earth, moon bounce and stuff like that. So during a typical contest, there's pretty much two general classes of, that do pretty well. The guys who are rovers, that is, you throw your entire rig plus your liaison rig, your 2-meter repeater rig into the car, and you drive around to strategic spots, and you try to work as many stations from different spots as possible. That's how you get multipliers. So those guys are called rovers. A lot of the guys, like myself, have set up our stations so that we can set up and tear down quickly. So, the more different spots that you go to, the more points you rack up. In fact, N9JIM won the contest last year as a rover. Previously, all the guys that were winning were on mountaintops. So if you have a good strategy, you can do really well in the contest. The other guys...
Go ahead. No, I was that's a quick question. When you're doing this roving, sometimes we see in the ham magazines there's a guy with a SUV and some unbelievably ridiculous antenna array on the roof of the car. Is that what it looks like, or is it more modest than that?
Well, yeah, for the VHF UHF contests, there's a bunch of guys who go kind of hog wild with their cars. 2 meters on up, right, and up to 10 gigs and so forth. And their cars look like a tree, I guess, with antennas all over the place. For our 10 gig and up contest, things are a little bit more modest. Usually the rigs are small enough so you can throw it in the back of the I happen to drive a Prius, so I've got it pretty much wired up. So I've got a telecom battery in the spare tire area and run a big cable out to my rig. And whenever I stop somewhere, I just stop the car. I don't turn it off because the Prius is, basically a generator on wheels. And I plop the tripod down, throw the rig on top, set up the antenna, I'm ready to go. So that's, kind of high-speed roving. The guys, so it doesn't have to be a big station. It could be fairly modest, actually. And I've also put a what they call a slot antenna for. It's a kind of an omni microwave antenna at 10 gigahertz. So I could be rolling down the road and chatting with somebody on 10 gigahertz just the way you would do it on 2 meters. The other guys on the mountaintops tend to be the bigger stations. They'll have bigger dishes, more power. Some of them will have generators and other stuff. And they can reach out pretty far. But, of course, they're not changing location. So they have to rely on the rovers because, gathering the points is kind of reciprocal. We rovers can gather more points by the more places we stop at, but they also get more points by working us in each different spot. So, we kind of complement each other. And then there's the guys who don't go out at all. A couple guys have microwave dishes on their HF towers with a dish positioner, a rotator, and they sit at home in a nice, comfortable, air-conditioned shack, and they can work everybody down the valley. So, yeah, there's all kinds of different styles of operating.
And when you're operating, what mode is used? Is it sideband or CW or what?
Yeah, for the most part, we're doing single sideband, just because there's a lot of no-code guys, and they're used to talking over voice. So that's not bad. We typically kind of do a setup over the repeater system or liaison, be it, whether it be 2 meter simplex or over the repeater system. And we'll kind of tell each other a hint about kind of which direction or what spot we're in. We use what's called Maidenhead grid squares. We use 6-digit Maidenhead grid squares, and that kind of, more or less pinpoints your location. So there's some kind of handy calculator apps. I think one by Nick, Hamlog, has a grid square calculator in it. So we use that to kind of figure out which way to point our dishes. It gives you the azimuth, direction.
So in that sort of app, you can put in your present location and then punch in someone else's, and it'll tell you the azimuth?
Actually, it's easier than that. So Nick has got it so that it's basically taking your GPS information off your phone, which is there all the time, and it automatically can update your location. So you only have to type in the other guy's location, and that gives you a bearing.
Oh, nice.
With your dish. So that's really nice. Thanks, Nick. And, okay, so, once you kind of have a general idea which way the other guy is, one of you guys will agree to put up a carrier, just a CW carrier or something, a signal, so that the other guy can kind of swing his dish around and kind of find out where you are, I guess. So as he pans his dish across the horizon, your signal will pop up out of the noise, and he'll adjust his dish to kind of optimize that signal, and then you'll holler at each other over the repeater to switch places. So he will listen for, let's say you will listen for him as he puts his carrier up, and you'll optimize your dish. And once that's done, you holler at each other that you're both ready to go, and you make the QSO.
So it sounds like kind of like any contest, except you have some pre-arranged coordination. Otherwise, I would imagine as you go for long distances, you could tune up and down the band and never hear the other guy because your antenna is pointing the wrong direction and the signal is very weak, and you really need that kind of coordination to make it work. Well,
that's pretty much it for the most part. One thing we kind of do, especially on the mountaintops, is they'll choose a particular frequency to squat on, and they'll stay there for the entire contest. They usually do that because maybe there's a microwave beacon on that same mountaintop that'll overload their front end. So they try to move away from it, and they'll park on one particular frequency and just let everybody know, hey, we're over here. So anytime you want to work those guys, you just point at them, dial in the frequency, and away you go. However, there have been a lot of times when there's kind of random stuff where two guys are, say, talking across the valley, and you're finishing up a contact, or you don't have anything to do, so you're just kind of panning around the band, and you run across these guys, and then you dial your dish into whoever's the strongest signal is, and give them a call and actually make a random contact. It's called tailgating. So, yeah, so it doesn't have to be necessarily through the repeater. It could be, all kinds of different things. This is what makes the contest fun. It's totally random.
Yeah, it sounds like it's some random contest element, but also a lot of forethought in putting your station together. And I want to get into the hardware of the station, but before we take a break, could you describe what your portable microwave station consists of? What are the components, sort of the big pieces of that gear? Because when we think about our normal a Go Box radio, you've got your ICOM 7300 or your KX3, or and that's like your radio, and then maybe you have a battery. So what are you hauling out in your portable rig? Okay,
so the first piece of it is the IF rig. When I say IF, it's really a 2-meter or 440 or any other rig that you happen to have. And that does all the modulation and the real receiving, demodulating of the SSB and all that stuff. We typically modify it to get the power down so we're not blowing out the mixer and stuff like that with several watts. The mixer can only take a few milliwatts before it goes bye-bye. But there are other rigs out there that are pretty good for this. Ideally, it's an FT817. That's one of the most popular. Also, Elecraft has done us microwave hams a big favor by putting a 2-meter module in the KX3. So the KX3 is also a great transverter rig. There are other ones that are, basically other, like your TR751 and some other rigs that could be modified for this. Second piece is the transverter itself. Transverter stands for verter means convert to a different frequency. So what it does is take your 2-meter and 440 frequency and translate it up to the microwave bands. And maybe as part of that, you also have a power amplifier and a low noise amplifier and stuff like that. And the final piece of this is the antenna itself, typically a dish antenna, and the thing that supports it, a big tripod. You want a good enough tripod so that it doesn't fall over in the wind. So those are the basic pieces of it.
So some of the microwave radios I've seen are have a bunch of little boxes and tiny rigid coax interconnect, and it looks like there's a lot of assembly and construction there. So we can dive into that in a little bit more detail. Before we take a break, is there anything else that you want to touch on about operating? Or
I guess the thing about operating is it is definitely an outdoor activity. When you go out, wherever you go, some places it's super cold. Depends on what time of the year you're operating. Out here in California, it gets super hot down in the valley, 110. So it's kind of like field day kind of in motion. So you have to be prepared for everything.
So it sounds like any sort of field contest kind of preparation is good. Bring a hat and sunscreen and water and a jacket, depending on which end of the spectrum you're going to hit in the weather.
Yeah, definitely. And it also helps to bring at least one other guy along, just, for safety reasons and other stuff.
Yeah, sounds like a good idea. Okay, so let's take a quick break, and we'll be right back to dive into the components in more detail and get some advice on how to build your first microwave radio. We'll be right back after this. This episode of The Workbench is brought to you by Autodesk Eagle PCB Design Tools. All of our projects we're doing on the Workbench use Eagle. It's great for schematic capture and board layout. You can easily generate all of the output files necessary to manufacture a circuit board. And whether you're building one board or 100 boards for your friends, use Eagle tools because they have really excellent support. They've got a great library of available components. It's widely used amongst the maker and the professional board design tool. You'll enjoy using the tools, and there's a lot of great new features. Check it out at autodesk.com/eagle, and you could download a free copy of the PCB design tool today and get started doing your project. So, Brian, what I want to do is take this to the next level of detail for the building side of things. Let's say that you're a listener and you go, well, Brian, that sounds really interesting. I want to get into microwave radio. I'd love to try a contest. And I know kind of the basics of what I need in my radio, like you described it just before the break. But could you walk through what you would get for your first rig? So what stuff would you buy? Where would you get it from? What would those components look like?
Okay. So there's different levels of sort of assembly, I guess, if you want to call it that, from several vendors. Especially the one I'm thinking of, especially is over in Germany. It's called CUNY Electronic, also known as DB6NT. He sells complete transverter kits. It's machined aluminum modules with everything in there, tuned up to perfection. Pretty much plug and play. Just hook up the power, hook up your IF rig, whatever you have, adjust however much power you need to make this thing work, and then hook it up to an antenna. And with 100 milliwatts, or sometimes more, depending on which band you're on, you can be on the air pretty much immediately. So that's kind of at a very high level, one way to get started. Or so you could buy a used transverter from one of your friends if it's already been built and working.
So let's take a look at that particular brand that you just mentioned, the guys in Germany. So this would be what, a 10 gigahertz radio transverter?
He makes transverters basically from I think 220 all the way up to 47 gigahertz, and especially 10 gigahertz and 24 gigahertz. Actually, complete kits. Basically, a complete transverter plug and play up to 24 gigahertz. Beyond that, it's mostly kind of components, and you kind of have to figure out kind of how to glue them together. They're built, so you're not messing around with wire bonds or microchips or anything like that, but there's still some assembly required. Whereas some of his other modules, you just add power, your rig, and an antenna, and you're on the air. So those are kind of the pre-built modules that he has. Now, going down a level, there are kits where they give you the circuit board, the enclosure, a bag of parts, and instructions. CUNY, who's over in Germany, and local U.S. company, Down East Microwave, who's in Florida, sell complete transverter kits, all the way from, say, 220 all the way up to 10 gigahertz. And you put them together yourself. You generally have to learn surface mount soldering techniques. Most of the parts are like 1206, so they're pretty big surface mount parts, easy to handle. But, there is some assembly required. And the way these kits are is what makes it nice is that you don't really need a whole bench full of microwave equipment to test these out. The DB6NT in particular only needs a voltmeter to get tuned up. So that's pretty good.
In their transverters, you said they'll go up into the 10 gig, 24 gig bands like you're talking about with the roving contesting.
Yes. Mm-hmm.
How much? Well, yeah, that's my question. How much power would something like this put out?
So as you go up in frequency, there's a little less power that gets squirted out the coax. At 10 gigahertz, it's about 100 milliwatts, or maybe a little bit more, which is actually, you'd be surprised how much signal that is. It's quite a lot. At 24 gigahertz, you're maybe getting a few milliwatts out, which is still pretty good. As you go up in frequency for the same size dish, you get more gain. So, for example, your typical DSS dish that you find on everybody's house, a lot of people repurpose those for their dish antenna, and that little thing at 10 gigahertz has about 30 dBs of gain, which is 1,000 times. No, is that right? 10,000 times a milliwatt, whatever. And at 24 gigahertz, you get even more. So, for really not much power, you can get a lot of signal. And as you go down, say to 5 gigs, 2 gigs, 3 gigs, and so forth, transistors that put out more power get cheaper. So those transverters are actually available in several watts output power. So just hook it up to a little, beam antenna or a dish or something, and away you go.
So it sounds like if I were going to, if I had all the money in the world and was just going to go buy a portable station, I would get a radio for the IF, like a 817, and then I would go get one of these transverter modules, which will take me up into the desired band, and in a dish, and I'm pretty good to go. Is that about it?
That's pretty much all, the entire system.
So the big question there on cost is, what did those transverters sell for? Are these hundreds or thousands, or how much does something like that cost?
Let's see. A fully assembled transverter, 10 gig transverter kit from DB6NT is about €600. That's about $600 or $700. Which
okay,
is not
so that's
cheap.
not too bad.
No, it's about the cost of a regular rig, I guess. About the cost of your IF rig. And usually the dishes are pretty much free. People will be happy to give you their old DSS dish, and you kind of add a feed to it, which could be as simple as a plumbing pipe cap with a probe stuck in it. No, actually, people do this. So a lot of the guys talk about waveguide. People know waveguide as being this kind of long, square, kind of clunky thing. A lot of us build our microwave stations from Home Depot. So you get a 3/4 inch plumbing pipe, and with the appropriate bends and things, you can actually shine it into your dish, and that's your antenna feed. So creativity is one of the things we do.
So you could use a copper pipe as your waveguide.
Yes, you can.
Wow, I'll be darned. That's yep. Amazing. I've never seen that. I don't know why. I always assume waveguide has to be rectangular because that's what it always looks like.
Well, it turns out that circular waveguide is actually a little bit less lost than rectangular waveguide, and rectangular waveguide is far less lossy than, say, coax. Coax is probably the worst. So guys, if they're kind of want to do a home station on the cheap, they'll run copper pipe out the shack and up the tower to their dish, and they'll have a piece of flexible waveguide at the dish so they can rotate the azimuth, and they're on the air.
So while we're on waveguide for a second, could you describe waveguide? So for the listeners who they know what a coax is, but they've never seen a piece of waveguide or know how it works, could you describe kind of the basic idea?
Oh, that's a good question. There's a whole mathematical description you can get into, but basically, if you take a little bead and you bounce it down a tube, it'll go kind of bouncing off the walls of the tube and out the other end, right? And as you squeeze the waveguide smaller, that little bouncy ball has to go bouncing at a faster rate. So basically, as you go up in frequency, the smaller the waveguide is. And the waveguide is sized so that it's a kind of submultiple of a wavelength or a wavelength that'll kind of propagate down this waveguide or bounce down this waveguide. A waveguide is very much like your plumbing pipe. It's a high pass filter. So if you, for example, shine a flashlight down your copper water pipe, you'll see light coming out the other end. If you try to squeeze an AM broadcast signal through it, it won't go. So it's kind of like trying to squeeze an elephant down a copper water pipe.
So Brian, how does the wave actually propagate through the waveguide? Does it propagate along the surface or be in the air between the sides of the waveguide, or where is the wave actually existing?
It's actually, how do I say this? It's actually propagating through the air down the waveguide, but reflecting off the metal in the waveguide. So
if you had a bead and you dropped it into a plumbing pipe, so that makes sense now with your explanation.
Yeah, that's essentially it. Without getting super technical, I could talk about waveguide modes like TE01 and all that stuff, but everybody would probably go to sleep if I started going down that road.
So is there much attenuation in the waveguide, or could you make it fairly long?
It turns out that waveguide, properly, cleaned, obviously spider webs and dirt are going to sort of absorb some of that RF energy. But if it's clean, there's actually very little attenuation down a waveguide. So if you look at some of the big, say, broadcast stations on, what used to be the UHF band, they'll actually send signals at 440, 450 megahertz, wherever it used to be, up a big waveguide, up a 2,000-foot tower. So, instead of sending it up coax. Nowadays, they put the transmitters at the top of the tower, but in the old days, they used to send the stuff up by basically, not even sub-microwave waveguide. And, of course, the big communications sites that you see on top of the mountains are all fed by waveguide rather than coax, just because it's a lot less lossy.
So when you see these old sites like the old telephone company microwave relay sites, and you see these big horn antennas, so the horn antenna, how does that work? The waveguide comes into the horn, and then what happens? So
for a horn antenna, you can think of it as a transducer. So a waveguide has an impedance of about, 200 ohms or so. And I believe free space has got an impedance of about 600 ohms. So as you come out the end of the waveguide and go into the air, you basically flare this waveguide out, and it actually provides an impedance match to free space. Now, you can change the dimensions of this flare, for example, by making it longer, and that tends to focus the energy more in one direction. So if you really want a very sharp beam, you kind of have a very long sort of taper out the end of the waveguide and into the air. If you want a little broader pattern, you basically flare the waveguide and it's a little shorter, and it makes a kind of a more like a big teardrop shaped beam.
So do hams ever use horns in these contests? I mostly see reflectors, like parabolic reflectors, dishes.
Yeah, reflectors are more efficient because what they do is when the energy comes out the end of a waveguide, it's sort of more or less coherent, but not totally. So when you shine it at a parabolic antenna or a section of a parabolic antenna, it tends to make all those waves kind of parallel. So therefore, you get more gain off of your, when I say gain, in antenna speak, that means directionality or focusing of the energy, not like an amplifier gain. So the more you focus the energy, the narrower the beam, and of course the more energy is concentrated in one sort of direction.
So getting back to what would you build for your first rig? So if you didn't buy the German solution, you said, well, I want to kind of roll my own. Could you save money by doing it yourself?
Actually, yes and no. Depends on the availability of parts. If you happen to live near a junk store that's got a lot of this stuff and they don't know what to do with it, or you go to a swap meet. A lot of swap meets have microwave stuff. You can sometimes pick up parts and things pretty cheap. However, you kind of have to know what all these parts are, or you can wind up with a pile of junk that maybe isn't very useful. So if I was going to advise a beginner, I would say either go build a kit from one of these two vendors, Down East Microwave or CUNY Electronic, or buy a fully assembled one. Just pay the money, get started, and get on the air and have fun. You can spend hours and hours sort of characterizing all the parts you pick up at the flea markets, and by the time you get through with all that, you'll spend too much time wasted and probably too much money. So yeah. The other thing for beginners is, if you're not really sure whether you want to get into this or not, go find a club, go find somebody in your area who's already on the air and kind of buddy up with them. A lot of times, a lot of us have loaner rigs. So, if there's an outing or a contest or something like that, tag along. Maybe they'll give you a loaner rig to try out and see if you like it or not, get a taste of it.
So my impression of the microwave crowd is, if you take the typical ham radio group, which tends to be very welcoming and inclusive and want to bring new folks into the hobby, the microwave guys are kind of like that and then more. I think they're super welcoming and would love to have you along.
Yeah, they'll fall all over themselves trying to help you.
Yeah, I've just been just really impressed with the crowd. So I know here in Northern California, we have at least one microwave club locally called the 50 Megahertz and Up Club. And I know down in Southern California, there's the San Bernardino Microwave Society, which gets members from all over Southern California, and they have a lot of activities too. And they also seem very happy to not only share their knowledge and experience, but also their equipment. And I don't mean just loaner radios, but like test equipment and mentorship and helping people kind of build their radios and get going. So I think it's a super helpful crowd from what I've seen.
Yeah, actually, let me mention some of the clubs, because you have a wide area listening audience. Just kind of mention clubs in various areas. In sort of the eastern part of the U.S., there's Northeast Weak Signal Society, or NEWS, kind of in the northeast. In the south, Florida area, Virginia, Southeast Microwave Society, I believe. I'm probably wrong there. In the central states, there's a Central States VHF Society. In Texas, there's North Texas Microwave Society. And let's see, Southern California, you mentioned San Bernardino Microwave Society. There's also a group in San Diego Microwave Group. And Bay Area is the 50 megahertz and up group. Unfortunately, I think there's a group up in Seattle, but I don't know if they're real active up there. There's a guy, Randy, W6RWN, who used to live in the Bay Area. He'd be dying to talk to somebody if anybody's up in the Seattle area. But yeah, there's groups all over, not necessarily clubs, but either individuals. There's a whole bunch of people in Colorado, Great Lakes, and so on. So it's not really hard to find somebody who will want to hook up with you on microwave and share their experiences. And, even if you're not geographically close, microwaves can go a long way if you build your rig, properly. Ground to ground microwave at 10 gigahertz is not unheard of. And in fact, I believe even the 24 gigahertz U.S. record was set from Texas to, I think, Mississippi or something like that, pretty much ground to ground. So yeah, all kinds of things are possible. So, find somebody who's more or less kind of in your area and talk to them.
Could you tell us a bit about the microwave update events that come up every year?
Some of the activities that we do in our microwave, say, groups around the country is hold conferences. The big one is called Microwave Update. The reason for that kind of funny name is there was a guy that kind of started a microwave gathering. He was in Colorado. and Estes, Colorado, I believe it was. Back in the, I guess, late 70s, early 80s. And it was kind of an informal gathering. And it was such a popular thing that, like, a year or two later, they decided to have another one. And they, from then, called it Microwave Update just because it was an update from the original conference. So thereafter, it's been called Microwave Update. There are also other VHF conferences that happen pretty much all over the country. Just look in the back of QST or QEX for the announcements, and you'll find out when and where they're going to be.
So this year, I think Microwave Update's in the Bay Area.
Yes. So it's going to be held somewhere in the Bay Area. I think it's going to be in Santa Clara at the Biltmore Hotel. We had that probably several times out here, and so I guess they're going back to the old place. It's pretty good. You get to meet all different kinds of microwavers. They have a swap meet there, so you can find parts. Very often, vendors will show up, and you can look at all their goodies. And they have really, really good talks, both for, say, the beginner and the advanced guys. So if you're out in the Bay Area in October, I don't remember the exact date, but plan on stopping in. I think you'll have a good time.
Well, while you're describing that, I just took a quick look here, and it looks like it's October 26th to the 29th. And I think that's a week after Pacificon. So if you really want to get your dose of ham radio events, come to the Bay Area for Pacificon and stick around for the Microwave Update, and you'll really be radioactive by the end of that.
Yeah, unfortunately, the last few years, they schedule these microwave updates in other parts of the country at exactly the same day as Pacificon. So people kind of had to make a choice. But this year, because the guys out here knew about Pacificon, they kind of tried to plan around it. So that's good.
So we've got our rig. So we've got our IF radio, or maybe an FT817. We've got our transverter. We've got our repurposed dish antenna, and some batteries or power supply we could take to the field. So we got everything we need to go operate. So
almost.
What are we missing?
Last item.
Yeah.
You need a tripod.
A tripod. Okay. Any old tripod will do, I suppose.
No. Let's see.
Of course not.
Your rig, let's see. If you stack your IF rig, a transverter, a dish, now maybe you're about 25 or 30 pounds. Yeah, my transverter, because it's dual band and it was kind of hacked together over the years, weighs 40 pounds just by itself. That's without the dish and everything else. So I need a good sturdy tripod. And you have to be prepared. Sometimes it gets windy. So if you got this big wind sail sitting on top of a stick and wind comes up and down you go, right? There goes your investment. So you want to have something that's going to stay on the ground pretty well.
So is there any kind of tripod that you look for that it does a particularly good job? I mean, a photo tripod is probably too light, like the normal consumer photo tripod.
Yeah, a good professional photography tripod is about the minimum. There are the kind of really popular heavy-duty ones are, I guess, the Hercules and, what's the other one? Gibraltar, I guess. Gibraltar being kind of like the very, very heavy-duty studio broadcast style. But
what about
really expensive.
How about like a surveyor's tripod?
Yes, people are using surveyor's tripods. And I have a picture of one fellow that used to be out in the Bay Area, Dave. He mounted his dish and everything on a Black & Decker Workmate. And that worked out pretty well. It worked great. He had his operating table and his dish mount and everything, and he could sit down there and operate comfortably. So
that's great.
Yeah, okay. Don't have to spend a lot of money. Just go to your local hardware store. Yeah.
Okay. Yep. So besides my rig and now my tripod, I've got everything I need to get there or to maintain all this. Do I need any kind of special test equipment or tools to make this happen?
Well, in an ideal world, yes. However, if you don't happen to have a bunch of fancy gear or the budget for a bunch of fancy gear, there are things you can do on the cheap that will get you up and running pretty well. To his credit, a guy, Paul Wade, out in the Northeast, his call is W1G8Z, has made it a point of putting together a whole bunch of kits and little doodads that will help you put your microwave station together or just do general testing. So he makes these little kit modules. He's got a little power meter that'll go up to 10 gigahertz, made out of, I think, an Analog Devices, power meter chip. You slap it together, glue on an SMA connector, and you've got a low power meter. It won't handle watts; it'll handle milliwatts, but it certainly will measure stuff up to some high frequency. The other stuff he has is actually boards and components where you can go down to another level. We talked about pre-built kits. So if you want to go down to the next level, you can get circuit boards and parts and put together something. And for example, DB6NT, CUNY Electronics, sells a kit version of their transverter for about $300. So that's considerably less than the one that he puts together. And basically you line it up with just a voltmeter and the noise in your receiver. So yeah, almost no test equipment at all. And Paul has, taken cheap to a new height by basically doing microwave circuits up to 10 gigahertz on FR4 with pipe cap filters and parts you can just get from the mini circuits or DigiKey catalog. So for maybe $100, you can get on the air with a transverter from him. Granted, it takes a little bit more sort of expertise to build one of his because it's not like a heat kit, but with the help of some good mentors, you can get this thing up and running. And again, I go back to getting enlisting local microwavers to kind of help you out, because chances are there's one guy in the neighborhood that happens to have a whole bunch of test gear that is more than happy to help you out, like maybe me.
Yeah, it seems like the community really helps. If you're lucky enough to be in an area where there's other guys who are doing this, that would be really a essential way to kind of get off dead center. Because I guess you can't really find a lot of documentation about this sort of thing except websites. I mean, there's no Dummy's Guide to Microwave Rig Design, right? I mean, where do you begin? Are there any websites that you would suggest people go to for information, especially as a beginner?
Actually, yes. I wrote down a whole bunch of books. But, for example, the Radio Society of Great Britain publishes, and you can get this from HRO or Amazon or whatever, the International Microwave Handbook, which has been out for quite a number of years. This is, I think he's on revision 2 or something like that. So he's got a lot of kind of old concepts and old pictures and gear in there from kind of way back, but all the basic principles, for example, like how a waveguide works and all that stuff, it's all explained in detail there. And he's updated it to include some of the more modern parts and techniques. So that's a really good book to get started. That's kind of where I cut my teeth. And the other book is the Microwave Experimenter's Handbook from the ARRL. That's another good source. QEX has often a lot of really good articles. The old back issues of Ham Radio Magazine, QEX, sometimes QSD had some of those things, but definitely Ham Radio Magazine from the old days has a lot of really good stuff and fundamentals and things. So, those are well worth checking out.
Now, I think Ham Radio Magazine might actually be available online somewhere for free. I know there are some old electronics magazines. Do you know if that one is available?
I don't know. I haven't looked for one online. I think I managed to have most of them from somewhere anyway, so I never bothered to look online. But certainly you can go look there, and there's a lot of information from guys who are doing microwave. You can look at things that they built. There are many YouTube videos that do a really great job of explaining some of these things too.
Wow. So it sounds like RSGB is a good place to start. And of course, you can order anything from them and they'll ship to the U.S. Not a problem at all.
Well, they're available actually through QST.
Oh, does
ARL.
The ARL sells them? Oh, excellent. Even better.
Yep.
So what about if I need any special components or anything? Are there any web stores or sources for microwave components, connectors, little sub-assemblies besides the ones you've mentioned? Are there any favorite haunts for finding that kind of surplus stuff?
Well, yeah, locally in the Bay Area, we have HSC or Halted Supply Company. I forget what it is. One of the sad things is that a lot of the surplus stores have kind of gone away around here, or some of the radio surplus. There used to be an outfit up in Concord that had a whole pile of microwave stuff. It kind of comes and goes. You find a lot of it at swap meets. Best place is to go to a local ham and trade. But if you don't happen to be close to any of that stuff, you can get components from mini circuits. They sell connectorized stuff. You can buy the surface mount components if you decide to build your own. So, at a level below the sort of store-bought stuff, you might invest in a good microwave switch relay, the TR switch. I believe that a lot of these kit transverters need an external microwave switch, so you might want to look for one of those. They're actually quite cheap on eBay, and also you find a lot of microwave parts on eBay too. But drilling down more on the parts part, there's mixers, there's amplifiers. Amplifiers are a particularly good deal. With the advent of the something called an MMIC, so that's called a monolithic microwave integrated circuit, MMIC. It's basically they took some transistors, glued them together, and put them in a tiny little package, and they're good from essentially DC to daylight. You can actually from it used to be RFMD, but now they call themselves Corvo or something like that. Mm-hmm. You can get a 4-pin chip that properly biased and mounted will go up to something like 13 gigahertz. So all you have to do is just add power ground properly, and a proper 50 ohm input and output, and this thing will go from DC to daylight with something like 15 to 20 dB a gain. So, yes, we live in amazing times.
So like you were saying earlier, as the commercialization of the microwave bands progresses, the industry throws off a lot of great technology that we could take advantage of. So that it seems like that's really true, especially like in this IC world, because so many of the consumer or even industrial microwave products are being consolidated into integrated circuits, and whether it's amplifiers, mixers, switches, all that stuff is going to be standard catalog parts. So I think it'll be even easier making fairly sophisticated stuff with these off-the-shelf parts.
Yeah, and actually that's kind of the principle behind Paul Wade's little boards, is that his mantra is that gain is cheap. And he's right. I mean, for at least up to a certain frequency, you can just buy a fairly cheap IC, a couple of bucks, and stick it on one of his boards and plug in a couple pipe cat filters, get them all tuned up, and be on the air. Another component that you need to look out for, and this is a very key component of any microwave system, you have to be on frequency. So, and this is the hardest part of any microwave radio, is kind of the local oscillator, getting it stable, clean. By that I mean low phase noise, low spurs, and stuff like that. Fortunately, even those are coming to fruition. TI, Maxim, probably Analog Devices are making chips that go in, ICs that go into the microwave region with their own built-in voltage-controlled oscillators, and you essentially, do a PC board, match it properly, program it with whatever your favorite, microcontroller is, and you've got a beautiful LO. Of course, they need to be referenced to something, so we microwave amateurs typically, get a 10 megahertz oven-controlled oscillator. Those are typically about $15 to $20, and they're very stable once they're warmed up, and we use those as our frequency reference. And in many cases, we can get down to, several tens of hertz accuracy at 10 gigahertz. You think about that, that's pretty amazing.
So now, let me walk you back for a second. So the IF radio that we're using in our sample first-timers rig, let's say an FT817, is that thing stable enough to work as you multiply it up to 10 gigahertz, or do you need the TCXO, or do you need some external frequency reference to lock the synthesizer? How do you keep it on frequency?
Yeah, well, as an IF rig, since we're only operating at 2 meters, the TCXO on the 817 or even the Elecraft is stable enough to do single sideband, very narrow band CW up in the microwave region. The 2 meters is not going to drift that much. However, when you start, your local oscillator is operating at, say, in the 10 gigahertz range, or maybe the 5 gigahertz range, and you're outdoors in the wind and so forth. If you just try to, say, have an ordinary crystal oscillator, maybe if it's not compensated, or even if it has an oven, if it's not properly designed, it's going to drift all over the place. So that's why we need a 10 megahertz reference at a fairly low frequency that's super, super stable, and we lock that to our synthesizer or whatever it is our microwave source is. So there's kind of multiple factors to getting your signal stable up there.
So if you take our 817 as the example again, how would you actually take the 10 megahertz reference and lock the 817 to that, or is that, like you said, maybe that's stable enough, and what are you actually locking to that frequency?
Yeah, we typically don't lock our IF rigs. Usually we, on the bench, we, get them on frequency with our regular signal generators or whatever we have, and that's pretty much good enough. So, you could lock your IF rig by injecting sort of the reference frequency. I think the 817 and some of the other rigs don't use 10 megahertz. They use sort of an odd frequency. So it's a little bit cumbersome to kind of lock your IF rig. We typically just lock the local oscillator in the transverter, and that's usually plenty good enough.
Okay, so it's the LO in the transverter that is, if it's wobbling around, that's going to move the frequency. It's going to multiply it out to whatever the operating frequency is, so that error gets amplified.
Yes, exactly.
So what do you use for a reference? So you're out on the mountaintop with your rig and everything's all set up. Do you have a self-contained frequency reference, or do you use like GPS, or how do you get a very accurate time reference to make sure that local oscillator is locked?
So most of us use just an ordinary 10 megahertz oven-controlled oscillator that you can get on eBay, usually from China. I think their prices range anywhere between $15 and say $25, and you can either just put it inside the rig where it's out of the wind, feed it with 5 volts, and that'll give you a stable enough reference, 10 megahertz reference, that will in turn lock whatever your synthesizer is. It's typically some kind of synthesizer or locked. Sometimes we use this thing called a brick. It's kind of an old thing. Nowadays we use synthesizer chips. But that's usually sufficient to get it on frequency. And these fairly inexpensive oven controlled oscillators, they come out of cell sites and they're pretty good quality. If you want to go further, you can lock it with a surplus rubidium oscillator. Or if you really want to go the whole 9 yards, you can lock it to a GPS signal. The only problem with GPS is that if you're a rover, every time you move, you're going to be a little off frequency until the thing gets back in sync. So most of us just use a El Cheapo oven-controlled oscillator and be done with it. It's doesn't have to be terribly expensive.
So I've heard from time to time there's a flurry of activity on the repeater where guys say, hey, there's rubidium frequency references on eBay for $100 or whatever the magic number is. I guess that's what they're buying them for, is that reference oscillator. Yeah,
it's usually kind of for a lab standard. One of the downsides of these rubidium oscillators is they need 24 volts to operate at fairly high current. So if you're out in the field and you're running battery power, you probably don't want a rubidium. They're somewhat delicate. I mean, they're somewhat rugged, but at the same time, they're kind of delicate. You don't want to drop it on the ground. Typically used as a lab standard, or some guys, like me, would hook up a DC to DC converter to get it up from 12 volts to 24 volts and just turn it on when you're not really sure that, if you happen to think you're off frequency for some reason, you can kind of recalibrate your system. But usually out in the field, you try to prepare before you go out, so there's no surprises.
So I think we covered all the basics for your rig. Is there anything else that you would recommend for a new microwave operator that they absolutely have to have in their pile of goodies?
Well, I think, I know a lot of guys who just have that and they get on the air really successfully. Mm-hmm. Anything else, like alignment stuff and whatever, go to a club and use somebody else's gear.
Well, this really sounds surprisingly more approachable than I had expected. I thought it would be, well, here's the 24 components you need to go find. You need this amplifier and this attenuator and this fancy coax rigid cable and a bunch of commercial microwave stuff that you have to scrounge together and make it work. But it sounds like it's much easier than that.
Yeah, in general, you can make a very simple rig out of what the key component, the local oscillator, and even a mixer. Mm-hmm. So and the antenna. A lot of guys have actually gotten the air with just a milliwatt out of the mixer and have done really well. So it's all you're doing really is adding a front end to your IF rig to convert the frequency up and down. It's pretty much, that's all it is.
So, do you have any more last advice for folks that are starting out in this area?
Not really. I still kind of repeat that, go find some friends who are kind of active in your area and seek out their advice and see how they do it.
Sounds like good advice. So before we take off, do you have anything on your bench that's microwave centric? Or if not on the bench yet, what do you have in mind that you want to work on next in this area?
Well, what I'm trying to do is design a little circuit board that's kind of Arduino controlled. So I'm trying to design it so that it's kind of multiple use. It's going to be both a local oscillator and kind of a general purpose little signal generator. So, for example, Barrick is doing his antenna analyzer, right? What if you could have a little DFO in there where you can extend the range up to, say, 1.2 gigahertz or something like that? That would be a pretty cool antenna analyzer.
We've had a bunch of people ask us if the next version of the antenna analyzer would go up to 2 meters. So the idea that it would go to 1.2 gigs would like overachieve the goal. That would be awesome.
Well, I mean, there's a lot of guys with 1.2 gear, 1.2 repeaters and stuff. So, yeah, it's kind of beyond the range of most guys. I think most, ham guys go up to 440 or something like that. But, it's kind of nice to have a little bit more.
Sure.
Yeah.
All right.
Now, I didn't get into really I can dive as deep as you want. I can go down into sub-component level like mixers and circulators and stuff like that. But then I'd be really getting pretty technical. So I think this is a good introduction on, if guys are kind of like on the fence on whether they want to get into microwave stuff, I mean, I think this is a pretty good introduction.
So maybe if listeners have questions about microwave radio in general or advice on specific equipment or just need some help getting over the fear of getting into this space, feel free to shoot us an email. Send the email to workbench@hamradio360.com, and we'll forward it on to Brian and maybe get Brian back on to talk a bit more about microwave. And we also talked about having you and Barrick come back on the show and talk about what you were just mentioning, which is more RF test equipment that you could build. So we'd love to have you back for something like that.
Yeah, I could talk about RF, test equipment and actually surface mount techniques. I did mention that a lot of microwave, if you're going to build your own, a lot of the things you can't do it with wires. You have to kind of do it on a circuit board. And circuit boards at microwave are mostly surface mount. So you have to learn some microwave, or surface mount techniques, but it's not terribly, intimidating. There are some techniques. Actually, there's one tip I'd like to share with you guys. I know Jeremy at one time said he has a little trouble with soldering surface mount parts that are small. Here's a tip for you. You have your thin solder. Take an X-Acto knife and just slice off a little sliver of it off the end of your solder. And when you're soldering down that surface mount component, that helps prevent application of solder. This happens to me. I'm soldering some surface mount part with, my solder, and my soldering iron and my solder looks gigantic compared to the part, and you tend to put solder all over the part, and it looks like a big solder blob. So if you want to meter out your solder, just take an X-Acto knife and just slice off a little bit of the solder, and then use that to solder the component down.
Well, that's a great tip. I was actually surface mounting a part on a little USB to serial interface chip the other day, and I did exactly what you described not to do, like blob a bunch of solder on there. So I had to solder wick it off. And had I thought about that, I would have tried it. So I'll note that for the next time I'm doing that kind of work. Hey, thanks so much, Brian.
Sure.
Thanks so much for coming on and sharing your experience. And we hope this motivates a few people to give it a try.
Yeah, I hope this was helpful.
I'm sure it's very helpful. So thanks a bunch for coming on, and 73s.
All right. See you later, guys.
All right, that's going to do it for this week's episode of the Ham Radio 360 Workbench podcast. You can find us online by visiting www.hamradio360.com. My name is Jeremy, KF7IJZ, and you can reach me on Twitter at KF7IJZ.
And this is George, KJ6VU. You could reach me at KJ6VU on Twitter or George at hamradio360.com.
Remember, next Tuesday will be the regular Ham Radio 360 podcast, and next Thursday will be the second episode of the Ham Radio 360 Field Radio podcast. If you have any feedback or anything in particular you'd like to share with us, including pictures of your BitX40 builds or any other projects you're working on, we'd love to hear from you. Please feel free to send an email to workbench@hamradio360.com. And George, if folks wanted to enter the PowerFilm contest, what was the URL again?
They go to powerfilmsolar.com/products/workbench and sign up.
Awesome. I can't wait to talk more about that in our next episode. In the meantime, keep building 73. Thanks for listening.
73s. Well,
Cool.
very good. So,
Yeah.
shall we do segment 3 here?
The third half of the show.
The third half of the show. Exactly. All right, Jeremy.
Jeremy, are you awake? Jeremy, are you awake?
So I understand the problem with your radio. So I got a question for you. What color is it?